What could have existed prior to the Big Bang? This exploration examines Michio Kaku's thoughts on the universe's origins, covering concepts from string theory to the potential existence of a multiverse, where our reality is just one of many. For Kaku, the question of cosmic beginnings is not just a scientific inquiry. It's a gateway to understanding the fundamental nature of existence and our specific role within it. Within the realm of science popularization, the name Michio Kaku holds significant weight. As a theoretical physicist and gifted communicator, he has committed his career to unlocking the secrets of the cosmos, acting as a vital link between the intricacies of science and the public's innate curiosity. His talent for translating complex ideas into understandable language has motivated millions to gaze at the stars and contemplate what truly lies beyond our own world. Kaku's personal journey is itself a remarkable story. From a young age, he showed an unquenchable curiosity for science and physics, a boy who chose building model rockets and imagining space voyages over traditional toys. This early passion propelled him to become one of the most distinguished physicists of our era, driven by a simple desire: for everyone to have the chance to look through the universe's window and see the reality he perceives. As we investigate the universe's origin, the Big Bang theory is an unavoidable and central topic. This groundbreaking concept proposes that everything we perceive originated from a singular, colossal explosion. To visualize this, think of a balloon expanding from a tiny point. As air fills it, its surface stretches outwards. This is a simple yet powerful analogy for how our universe began from an incredibly hot, dense state and has been expanding ever since. The expansion of the universe is more than just an established fact. It's a dynamic process that continually reshapes our perception of the cosmos. When you observe the stars at night, you are essentially looking into the past, as the light from those distant suns has traveled for millions of years to finally reach your eyes. Yet, the expansion continues every second of every day, with galaxies accelerating away from one another, making you wonder about the ultimate destination of this cosmic journey. One of the most compelling ideas arising from this framework is the theory of cosmic inflation. It suggests that in the moments immediately following the Big Bang, the universe experienced an incredibly rapid and exponential expansion, repeatedly doubling in size in a fraction of a second. While this concept helps explain the remarkable uniformity we observe across the cosmos today, it also deepens the mystery of what might have existed just before this inflationary period began. In our exploration of these questions, we inevitably confront concepts that can seem baffling, such as dark matter and dark energy. These enigmatic substances constitute the vast majority of the universe, yet they remain invisible and intangible to us. Their presence is like the air you breathe, essential and powerful but not always directly perceived. We know they are real only through their profound gravitational effects on the movement of galaxies and the path of light traveling through space. Symmetry in physics also offers a critical lens for understanding the universe's origins, as nature frequently reveals an inherent beauty and order that reflects the fundamental laws governing reality. To grasp its importance, consider a jigsaw puzzle. The final, coherent image only emerges when every piece fits perfectly into its designated place. Physics operates in a similar manner, with each law and particle playing a specific role in the grand design of the cosmos. Guiding us through these cosmic complexities, Kaku introduces string theory, a revolutionary framework that seeks to unify the fundamental forces of nature into a single, cohesive theory. This idea posits that subatomic particles are not points, but rather minuscule, vibrating strings of energy. The manner in which these strings vibrate determines the properties of all matter, suggesting that at the most fundamental level, everything in the universe might be more interconnected than we ever thought possible. From this foundation, the concept of the multiverse emerges as a profoundly fascinating possibility. What if our universe isn't unique? The notion that there could be an infinite number of other universes, each with its own distinct physical laws and separate realities, is both a thrilling and a mind-bending proposition. If life can arise in our universe, it raises the question of how many other forms of existence might flourish across this immense cosmic network. The paradox of time is another thread woven into our search for answers. What truly is time? While most of us see it as a linear progression, Kaku encourages you to consider it as a pliable, curved dimension. Adopting this perspective could radically alter our understanding of the past, present, and future, challenging the very idea that there must be a definitive beginning or an ultimate end. Ultimately, we reflect on how the Big Bang may have not only created the universe, but also brought time itself into existence. This is a challenging concept to fully internalize, but imagine that time, as we measure and experience it, was born in that initial moment. This profound idea has deep implications for our own existence and our ongoing quest to find meaning in a cosmos governed by intricate physical laws. Throughout this journey, Kaku, with his distinct approach, prompts us to see that the laws of physics are not mere abstract equations, but the very rules that shape our everyday reality, raising the question of whether science and spirituality might coexist. Could there be an underlying purpose to the vastness of the cosmos? As we prepare to explore these topics in greater detail, the invitation remains open to continue this journey of discovery. The universe is an immense ocean of wonder and mystery, and with each new finding, we move a little closer to understanding our origins and our place within it all. Within the expansive domain of science, Michio Kaku shines as a symbol of profound knowledge and relentless curiosity. But if you're not familiar with him, you might wonder about this theoretical physicist and science popularizer. To truly grasp his influence, it's essential to delve into his personal history and professional journey. Born in San Jose, California in 1947, Kaku demonstrated a deep-seated fascination with the cosmos from a very young age. This childhood passion drove him to construct a particle accelerator in his family's garage, a remarkably ambitious undertaking that hinted at his eventual career in physics. His academic path was just as impressive, beginning with a bachelor's degree in physics from Harvard University, followed by a doctorate from the University of California, Berkeley, where he fully dedicated himself to theoretical physics with a focus on string theory. String theory is a field that attempts to explain the behavior of the universe's most fundamental particles. Beyond his achievements as a scientist, Kaku evolved into an exceptional communicator, adept at translating the intricate details of science for the general public. He has made complex subjects both understandable and captivating through his numerous books, public talks, and television appearances, effectively bridging the gap between academia and everyday life. You might ask yourself why popularizing science is so critical. Kaku operates on the conviction that science should not be confined to laboratories and academic institutions. He sees it as the common inheritance of all humanity. By making this knowledge accessible, he hopes to ignite curiosity in new generations, encouraging them to question and explore the world around them. In our current age of information overload, the skill of distinguishing fact from fiction is more vital than ever, and Kaku's work plays a key role in promoting critical thinking across society. One of his most compelling contributions lies in his advocacy for string theory, which proposes that subatomic particles are not single points but rather tiny, vibrating strands of energy, presenting a truly mesmerizing picture of the universe. Kaku has investigated how this framework could potentially unify all of nature's forces and provide answers to some of the most profound questions about the cosmos's origins. The theory is so remarkable because it implies that reality is substantially more intricate and elegant than we can currently perceive. Beyond his scholarly pursuits, Michio Kaku has been a persistent champion for science in the media. His engaging personality and talent for simplifying difficult ideas have established him as a vital link between the scientific community and the public. Through his work on documentaries and TV shows, he has delivered the enigmas of the universe directly to millions of viewers. His infectious passion for knowledge and his gift for storytelling make even the most abstract scientific principles come alive. Kaku has also tackled pressing scientific topics, such as the rise of artificial intelligence and the search for extraterrestrial life, showing that his vision extends far beyond the realm of physics. He examines the ethical dimensions and societal impacts of scientific progress, serving as a reminder that science is not isolated from our daily lives. Instead, it is intricately woven into the human experience and our collective ambitions, prompting you to consider the role science will play in shaping our future. Another dimension of his work involves fostering a dialogue between science and spirituality, where he has considered how scientific discoveries might reshape our concepts of the divine and the transcendent. This multifaceted perspective demonstrates his commitment to integrating various modes of understanding. In a world where science and religion are often viewed as conflicting, Kaku creates a framework where they can not only coexist but also mutually enrich one another. Over the course of his career, Michio Kaku has authored numerous books that have garnered praise from both critics and the public. Titles like Physics of the Future and The Universe in a Nutshell showcase his unique ability to relate complex scientific concepts to everyday experience. Through these writings, Kaku extends an invitation for you to envision a future where science and technology will improve our lives in ways that are currently hard to imagine. The Big Bang Theory serves as a fundamental pillar of modern cosmology. When you think about the Big Bang, you likely picture a massive cosmic explosion, but that's a common misconception. In truth, the Big Bang wasn't an explosion in the traditional sense. It was the precise moment the universe initiated its expansion from an incredibly hot and dense initial state. The evidence supporting this theory is compelling, starting with observations of light from faraway galaxies. When you gaze into the night sky, you are not just seeing stars. You are peering into the distant past, as the light from these galaxies has traveled for billions of years to reach us. This has led to an astonishing discovery. Nearly all galaxies are moving away from our own, which indicates that the universe is continuously expanding. If you mentally reverse this process, it logically follows that everything must have once been consolidated into an infinitesimally small point. Hubble's law provides a clear mathematical description of this expansion, stating that the more distant a galaxy is, the faster it is receding from us. You can visualize this phenomenon by imagining dots drawn on the surface of a balloon. As you inflate the balloon, the dots spread farther apart from each other. The universe behaves in a similar fashion, with galaxies separating as space itself expands. This naturally leads to the ultimate question: what existed before that initial moment? What came before the Big Bang remains one of the most profound and unanswered questions in science. Researchers have put forth numerous hypotheses to describe the state of the universe prior to this event, but it continues to be a deep mystery. Some theories speculate about a pre-existing state of pure energy, while others entertain the idea that the universe undergoes endless cycles of expansion and contraction. What we can say with certainty is that at the instant of the Big Bang, the fundamental laws of physics as we know them began to emerge, giving birth to the cosmos you see today. The universe's first moments were a torrential flood of particles and energy, creating what could be described as a primordial soup. You might wonder how the elements we are familiar with, like hydrogen and helium, came into being during the initial minutes of cosmic existence. Physicists theorize this happened through a process called nucleosynthesis, where the first atomic nuclei were forged. As the cosmos expanded and cooled, conditions became right for atoms to form, which then gathered into the earliest stars and galaxies. It's truly a remarkable thought that the light you see from distant stars is actually an echo of those very first cosmic moments. When you gaze up at the night sky, you are essentially looking at the history of our universe written in light. Further supporting the Big Bang theory is the existence of the cosmic microwave background, which is the residual heat signature left over from that initial explosive event. This radiation acts as a fingerprint from the dawn of time, packed with data about the temperature and density of the primitive cosmos. To help you visualize it, think of a campfire that has been put out but still gives off residual warmth. This cosmic radiation is the lingering heat of the Big Bang. By studying it, we gain invaluable clues about the universe in its infancy. Over the decades, the Big Bang theory has been subjected to countless tests and observations, and it has grown stronger with every new piece of evidence. Yet, this doesn't mean the puzzle is completely solved. In fact, there are numerous unanswered questions that compel us to continue our exploration. For instance, what exactly are dark matter and dark energy? And how do they relate to the Big Bang? This theory doesn't just explain the universe's origin. It provides us with a framework for comprehending its evolution. It also connects us to deeper philosophical inquiries about our own place in the cosmos. What does it signify to be part of a universe that burst into existence from a single point billions of years ago? The implications are genuinely profound, urging you to contemplate the very meaning of existence. The search for our cosmic origins is an ongoing journey, constantly presenting new questions and unexplored possibilities. The expansion of the universe is a particularly captivating phenomenon that invites you to rethink your position in the cosmos. How can it be that everything we observe is moving away from us? This entire mystery began with the early 20th century observations of astronomer Edwin Hubble, who revealed that galaxies are not only incredibly numerous, but are also receding from us at phenomenal speeds. This discovery leads to a fascinating question. If all the galaxies are currently moving apart, does it stand to reason that they were once gathered together? The answer to that question forms the very core of the Big Bang theory, which posits that the universe originated from an incredibly hot and dense singularity, approximately 13.8 billion years ago. From that moment on, it has been in a perpetual state of expansion, much like a balloon that is continuously being inflated. Delving into this subject more deeply, you find that the universe's expansion isn't just about separation. It's a revelation about the fundamental nature of reality itself. Every galaxy you can see in the sky serves as a beacon, recounting a story of the past. The distances between these galaxies are always changing, which tells us that the universe is not a static entity, but a dynamic system in constant transformation. But how do we measure these vast distances and confirm they are increasing? Astronomers employ a tool called a spectroscope to analyze the light coming from distant galaxies. When they study this light, they observe that specific wavelengths are stretched toward the red end of the spectrum, a phenomenon called redshift. This effect happens when a light source is moving away from an observer, analogous to how the sound of a siren's pitch lowers as it speeds away from you. This evidence allows us to state with confidence that the universe is indeed expanding. This realization, however, prompts us to contemplate a much larger question. What is the ultimate destiny of this expansion? As the cosmos grows, the temperature of space drops, raising new possibilities. Will the universe eventually cool into a frozen, inert state? Or will it one day reach a point of equilibrium? This expansion is propelled by a mysterious force known as dark energy, which is thought to make up roughly 70% of the universe, and is one of modern cosmology's greatest enigmas. The concept of an expanding universe also encourages you to reflect on the nature of time itself, as time and space appear to be woven together into a cosmic fabric that is continuously unfolding. The universe's growth also brings us face to face with the ideas of the finite and the infinite. Is it possible for the universe to have an infinite volume but a finite age? Or perhaps there is a boundary to its expansion that will one day cause it to reverse, a notion that invites both scientific and philosophical speculation about a potential future collapse. All of this naturally leads you to wonder about humanity's role in this immense cosmic theater. It is undeniable that the universe's expansion serves as a powerful reminder of how small we are against the backdrop of the cosmic abyss. The Big Bang Theory is far more than a simple explanation of our origins. It is a gateway to our past, an invitation to probe the unknown, and a confirmation that the cosmos is a place brimming with mysteries, still waiting to be discovered. At the same time, this reality encourages you to marvel at being a participant in such a magnificent spectacle. The innate curiosity of humanity has spurred countless scientists to investigate the consequences of this expansion, prompting the question, are we the only ones posing these queries? Our search for answers drives us to gaze at the stars, to chase after knowledge, and to dream about what may exist beyond our own planet. With every new discovery and technological leap, we draw nearer to comprehending the mechanics of the universe. Space missions, advanced telescopes, and sophisticated computer simulations represent just a fraction of the instruments we employ in this pursuit. Yet, what's truly captivating is how each answer we find seems to give rise to a host of new questions. Ultimately, the universe's expansion isn't merely a physical event. It stands as a testament to our relentless pursuit of knowledge, connecting us to generations past who looked to the heavens and contemplated their position within the cosmos. Imagine, for a fleeting moment, that in the first instant of the universe's life, all that you know was compressed into a point of unimaginable density and heat. This idea, which we call cosmic inflation, is a cornerstone for grasping how our universe came to be. To visualize this, think of the universe as a rapidly inflating balloon, where points on its surface that were once close together are suddenly flung far apart. This process didn't just expand space. It laid the groundwork for how galaxies and all cosmic structures would form over billions of years. To truly grasp cosmic inflation, you have to journey back in time. In the immediate aftermath of the Big Bang, the universe was so dense and hot that our current laws of physics simply did not function. It is within this period that scientists believe an exponential expansion took place in a tiny fraction of a second. The proposed mechanism behind this event is a type of energy known as vacuum energy, though the exact cause remains a subject of intense study. Cosmic inflation does more than just describe the universe's initial growth spurt. It also elegantly solves several major puzzles that troubled the standard Big Bang model. For instance, it explains the remarkable uniformity we observe across the cosmos on a grand scale. Without inflation, it would be impossible to account for how regions of the universe, separated by immense distances, could share such similar physical properties. Furthermore, the theory of inflation suggests that minuscule quantum fluctuations in the density of the primordial universe were stretched into the vast structures we see today, such as galaxies, clusters, and even superclusters. You can think of it like tiny imperfections on the surface of a balloon that become significant wrinkles and bulges as it inflates. These initial irregularities were absolutely critical, acting as the seeds from which all known matter would eventually grow. Of course, the concept of cosmic inflation also brings forth some profound and intriguing questions. If the universe expanded so violently, what, if anything, existed before that moment? Did everything we see spring forth from absolute nothingness? Some physicists theorize that our universe could be part of an endless cycle of expansion and collapse, while others propose the existence of a multiverse, with countless other universes each undergoing its own inflationary history. It's truly staggering to consider that in such an infinitesimal span of time, the fundamental laws that dictate the functioning of our universe were permanently established. Cosmic inflation provides the very framework for understanding how the first particles came into being and the rules governing their interactions. This naturally leads to a fascinating question. Could there be other universes, each governed by an entirely different set of physical laws? The idea of a multiverse is deeply intertwined with inflation, hinting that our known reality is just a tiny fragment of a much vaster and more intricate cosmos. But how could a theory as abstract as cosmic inflation ever be verified? Scientists are actively searching for concrete evidence through astronomical observations and sophisticated space-based experiments. Among the most promising avenues of research is the study of gravitational waves, which are ripples in space-time that could carry information from that very early epoch of the universe. The possibility that an echo of inflation still resonates throughout the cosmos is a genuinely thrilling prospect. Exploring cosmic inflation also compels you to reflect on the nature of time itself. If time as we know it began with the Big Bang, what does that imply for our entire perception of its flow? In this context, inflation introduces another layer of complexity to our understanding of the deep, unbreakable connection between space and time. This journey into the past is an invitation to ponder your own place in the grand scheme of the universe. In the end, cosmic inflation is a powerful concept that not only helps explain the origins of our universe, but also raises profound questions about the very nature of existence. As we continue our exploration and make new discoveries, each piece of the cosmic puzzle brings us closer to unraveling the deepest mysteries of our reality. It's a humbling thought that we are part of a story far larger and more complex than we might ever have imagined. As we forge ahead, our relentless curiosity and the quest for knowledge will continue to propel us into the unknown, because the universe surely has many more surprises in store for us. Have you ever stopped to think about what our universe is truly made of? While most of us are acquainted with the ordinary matter that forms stars, planets, and ourselves, two other components lurk in the cosmic shadows: dark matter and dark energy. What are dark matter and dark energy, and why are they so essential for making sense of our universe? Dark matter in particular is a fascinating enigma. Picture yourself in a completely dark room, trying to find something you've dropped. You can't see it directly, but you know it's there from how it affects other items, or how shadows fall around it. In much the same way, we can't observe dark matter, but we can clearly see its influence through the behavior of entire galaxies. Remarkably, dark matter is thought to constitute about 27% of the total mass and energy in the universe. So, how can something so prevalent be so hard to detect? To grasp this, let's examine the way galaxies spin. Imagine watching a merry-go-round. If you only focused on the horses without considering the powerful motor driving them, you couldn't explain their speed. Dark matter functions as this unseen engine, supplying the extra gravitational force needed to bind galaxies together, and prevent them from flying apart. Dark energy, however, is an even more profound mystery. This force is credited with the accelerating expansion of the cosmos. Think about blowing up a balloon. Initially, the inflation is steady, but then you might feel it start to expand faster and faster. Dark energy acts like this accelerating puff of air, causing the universe not just to grow, but to do so at an ever-increasing rate, pushing galaxies further and further apart. But what is the true nature of this dark energy? Researchers have put forward a few main ideas. One prominent theory suggests that dark energy is an inherent property of space itself, a kind of vacuum energy that generates a repulsive negative pressure. Other hypotheses propose that it is a new type of energy field we have yet to characterize. The ultimate question remains: will we ever be able to directly observe and finally understand the force that makes up the vast majority of our universe? The dynamic between dark matter and dark energy is absolutely critical to the cosmos. You could envision a grand cosmic game of chess where galaxies are the pieces. In this analogy, dark matter sets the gravitational rules that govern how the pieces move and cluster, while dark energy is the invisible hand that relentlessly expands the board itself. The combined influence of these two dominant forces ultimately dictates the fate of our universe. As the scientific community delves deeper, each investigation spawns a host of new questions. What if we find that dark matter is something entirely different from our current theories? Or suppose dark energy possesses even more bizarre characteristics than we imagine? Any new insight has the potential to fundamentally reshape our entire understanding of the cosmos, propelled by an insatiable human curiosity to find answers to these profound mysteries. Current experiments are actively working to detect these phenomena, utilizing everything from powerful telescopes that analyze the light from distant galaxies to sophisticated particle accelerators designed to hunt for dark matter particles. Science is a continuous journey of discovery, and with every technological advancement, we move a little closer to solving these cosmic secrets. But the question then becomes, what will happen once we finally manage to perceive the invisible? The implications of truly understanding dark matter and dark energy are staggering. Such a breakthrough could revolutionize our concepts of space, time, and possibly our own existence. If we can finally decode the nature of these forces, we may also get a clear preview of the universe's ultimate destiny. Will it expand forever into a cold, dark void? Or is there a possibility that everything will one day collapse back in on itself? The puzzle of dark matter and dark energy extends beyond science into the realm of philosophy. It compels us to reevaluate our definition of reality and our own position within the cosmos. What does it mean to be a conscious being in a universe where the vast majority of it remains unseen? These inquiries launch us on a profound quest to better understand our own place in the grand scheme of things. In his own efforts to comprehend the universe, physicist Michio Kaku has explored these subjects extensively. He views the study of dark matter and dark energy as an indispensable step toward finding a unified theory that can explain all of nature's forces. Kaku encourages us to envision a future where these cosmic mysteries are no longer shrouded in darkness, but are instead brightly illuminated by human knowledge and relentless inquiry. Dark matter and dark energy represent far more than just abstract theoretical concepts. They are portals to a universe of new possibilities. As our knowledge grows, every answer we find seems to unveil a new set of questions, which is the very essence of the scientific endeavor. In this immense cosmos, where everything we can see is merely a tiny fraction of what truly exists, the pursuit of knowledge continues, fueled by our unquenchable curiosity. We can only wonder what incredible discoveries the future has in store. Symmetry is an elegant and powerful idea that lies at the very core of physics, offering answers to why things are the way they are, while also raising its own set of compelling questions. We observe symmetry all around us in the natural world, from the petals of a flower to the intricate structure of a crystal. But how does this concept relate to the very origin of our universe? It's crucial to recognize that in physics, symmetry is far more than just an aesthetic quality. It serves as a vital tool that allows scientists to decipher the fundamental laws that govern reality. Consider the laws of physics to be like a deck of cards for a game. Symmetry provides the unchanging rules that dictate how that game must be played. Without this underlying symmetry, the universe would be an unpredictable and chaotic place. Symmetry is also fundamental to the conservation of certain physical quantities. For instance, the consistent and symmetrical nature of physical laws over time is what ensures that the total energy within an isolated system always remains constant. Think of it like a perfectly balanced scale. If you add weight to one side, the other must adjust to preserve equilibrium. If nature lacked these symmetries, it couldn't maintain these crucial properties, and the universe as we know it would devolve into chaos. Have you ever stopped to consider why the fundamental particles that make up our world, such as electrons and quarks, even exist in the first place? The astonishing answer is deeply rooted in the principles of symmetry. The very existence of these building blocks of matter is a direct consequence of the deep, underlying symmetries that are woven into the fabric of the universe itself. In the world of physics, every particle is thought to have a corresponding partner with similar traits, a principle referred to as particle symmetry. This idea points to a fundamental pattern in the natural world that groups these elemental particles into distinct families. Without such symmetry, it would be incredibly difficult for physicists to forecast how particles will interact under different conditions. As you explore the concept of symmetry in physics more deeply, you discover that it comes in several forms. Among the most compelling is gauge symmetry, which serves as a cornerstone for the unified field theory. This ambitious theory aims to show how the universe's fundamental forces, like gravity, electromagnetism, and the nuclear forces, are all interconnected. You can think of gauge symmetry as an unseen force that links these interactions, enabling them to influence one another. Symmetry breaking is another vital concept, though it may initially sound like a contradiction. The universe can sometimes act in unforeseen ways, causing these perfect symmetries to fracture. Consider a flawlessly balanced puzzle that suddenly loses a piece, destroying its perfect arrangement. For scientists, this disruption can signal the birth of new particles and forces, which in turn helps us comprehend phenomena like the origin of particle mass. Indeed, the breaking of symmetry is essential to explain why certain particles have mass and others do not. Symmetry also compels you to contemplate the true essence of space and time. What would happen if time itself were symmetrical? In theory, this would imply that you could travel both forwards and backwards through time with the same freedom you move through space. Yet our reality is that time possesses a clear direction, always advancing forward. This temporal asymmetry hints at an intrinsic property of our universe that dictates the specific sequence in which events must occur. So, what does symmetry imply about the birth of our universe? To grasp its role in the Big Bang, you must understand that the cosmos was extraordinarily symmetric in its earliest moments. As the universe expanded and cooled, however, those initial symmetries began to shatter, giving rise to the rich diversity of particles and forces that we observe today. This entire process can be visualized as a magnificent cosmic performance, where symmetries gracefully dissolve to make way for the complexity of existence. Symmetry is also central to the ongoing quest for a unified theory capable of merging all of nature's forces into one. Prominent scientists, Michio Kaku among them, are convinced that a single, fundamental theory exists that can account for everything from gravity to quantum mechanics. Symmetry serves as the guiding principle that could ultimately lead to this grand unification. It is akin to searching for the master blueprint of an intricate tapestry, in which every single thread has a predetermined role and location. Furthermore, symmetry isn't confined to the realm of physics. It is woven into the fabric of nature itself. You can see symmetry manifested in biology, from the way plants grow to the forms of animals. Such parallels suggest the existence of universal principles that govern both the cosmos at large and life here on Earth. This profound link between physics and biology leads you to wonder if symmetry is one of the most fundamental characteristics of all reality. When you ponder symmetry, you might also ask what it means for us, as human beings, to inhabit a universe governed by these principles. Symmetry does more than just bring order to the cosmos. It offers a profound sense of beauty and structure. It serves as a reminder that, despite all our individual differences and societal inequalities, there is a deeper, underlying pattern that connects everything and everyone. Ultimately, symmetry is a foundational principle that allows us to decode the universe's greatest secrets. It demonstrates that order can be found within chaos and that nature operates according to rules that, while often complex, are fundamentally understandable. As our exploration of the cosmos continues, symmetry will undoubtedly remain a crucial guide, helping us to better comprehend our place in this immense and enigmatic universe. String theory represents a remarkable endeavor to consolidate all of nature's forces into a single, cohesive framework. But what is the real significance of this? To visualize it, you could picture the universe as a boundless ocean, where every wave and current corresponds to a fundamental force. Within this cosmic ocean, string theory functions like a maestro, orchestrating these disparate waves into a unified symphony of reality. At the core of string theory is the revolutionary idea that subatomic particles, which we have long pictured as simple points, are in fact tiny, vibrating filaments of energy. These strings are so minuscule that they are impossible to observe, even with our most advanced microscopes. The way each string vibrates determines the kind of particle it becomes, which in turn dictates the nature of the matter you see around you. It is a truly incredible thought that, at the deepest level of reality, vibrating melodies are composing the grand symphony of the cosmos. String theory aims to describe not just the particles themselves, but also the forces that govern their interactions. For example, even gravity, the very force that holds you to the Earth, can be explained as a product of these vibrating strings. To better grasp this, think of a musical instrument. When a note is played, its vibrations generate waves that travel through the air. In a similar fashion, the vibrations of these strings create waves that manifest as the fundamental forces shaping the entire universe. This deep connection between vibration and force is a paradigm-shifting concept that could reshape our entire understanding of physics. Within the framework of string theory, fascinating new questions emerge. If all matter consists of vibrating strings, then what are black holes? For a long time, they have been regarded as the universe's most inscrutable puzzles. String theory, however, provides a fresh perspective, suggesting that these cosmic enigmas could actually be a unique type of vibrating string. This idea implies that even the most profound mysteries of the cosmos may be integral parts of a magnificent, unseen harmony. One of the most captivating features of string theory is its proposition of extra dimensions. While you are familiar with 3 dimensions of space and 1 of time, The theory posits the existence of additional dimensions that are beyond our direct perception. To understand why there might be more dimensions, imagine a sheet of paper that has been crumpled into a ball. From a distance, it looks like a two-dimensional object, but as you get closer, you realize it possesses a third dimension that was initially hidden from view. Have you ever considered the possibility that our universe isn't the only one in existence? The concept of a multiverse has long fascinated the minds of both scientists and philosophers. Imagine a boundless ocean of separate universes, each governed by its own distinct physical laws and filled with its own unique realities and potentials. This notion, which can seem outlandish or even like pure fiction, is a subject that the celebrated theoretical physicist Michio Kaku explores with great passion and inquisitiveness. Kaku encourages us to venture beyond the confines of our own cosmos, asking what if other, parallel universes exist, perhaps even containing alternate versions of ourselves. This is not merely a trope of science fiction. It is an idea rooted in credible scientific frameworks. The concept of the multiverse actually emerges from interpretations of foundational theories like quantum mechanics and the model of cosmic inflation. Quantum mechanics, for instance, posits that subatomic particles lack a fixed state until they are measured. This very principle has led some physicists to suggest that with every observation or decision, the universe fractures into multiple timelines. In this branching reality, a cascade of alternative universes is created where every conceivable outcome is realized. Consequently, in another universe, you might have embarked on a different career path, or you could be living in a world that is completely alien to this one. On the other hand, the theory of cosmic inflation describes how the universe underwent an exponential expansion in the moments following the Big Bang. This rapid growth not only forged the space we inhabit, but could have also spawned numerous distinct bubbles, or universes, within a vast cosmic multiverse. Each of these bubbles might possess its own set of characteristics, physical constants, and even dimensions. Can you fathom a universe where the force of gravity is more intense, or where time moves at a different pace? The very thought is captivating. Michio Kaku also highlights the critical role of string theory within any discussion of the multiverse. This theory proposes that all subatomic particles are, in fact, tiny strings vibrating in dimensions beyond our perception. According to this view, the various ways these strings can vibrate could give rise to different universes, each endowed with its own set of physical laws. Within this framework, the multiverse appears as a natural consequence, a grand stage where an infinite variety of universes can play out. This raises a compelling question. How could we ever confirm if these parallel universes are real? The path to an answer is far from simple. Science typically progresses through observation and experimentation, but the multiverse presents an extraordinary challenge. If these other universes are completely detached from ours, we might never be able to detect them directly. Still, some researchers believe that subtle imprints of these other realms might be detectable within our own reality, perhaps as anomalies left over from interactions between cosmic bubbles during the early expansion of space. The additional dimensions proposed by string theory can be thought of as hidden components essential to the very structure of the universe. If these foundational strings are indeed vibrating in a space with more dimensions than we can see, does that imply the coexistence of different realities? This is an intriguing notion. Consider a scenario where every unique vibration of a string within an extra dimension gives birth to a new universe, seamlessly weaving the concept of the multiverse into the fabric of string theory. and suggesting we are but one small part of a vast cosmic tapestry of alternate worlds. String theory also offers a path toward resolving some of the most persistent puzzles in physics. For decades, scientists have struggled with the monumental challenge of unifying quantum mechanics and general relativity. By proposing a more comprehensive framework that incorporates both of these pillars of modern physics, string theory presents a potential breakthrough. Is it not astounding to think we may be closing in on solving one of the most profound mysteries in all of science? However, string theory is not without its share of skepticism. A number of scientists raise valid questions about its capacity for empirical validation. In a discipline where tangible evidence is the ultimate arbiter, how can we embrace a theory that seems to lie beyond the reach of our observational tools? This dilemma forces us into a deeper reflection on the very essence of the scientific method and the ways we search for truth. The profound allure of string theory is rooted in its mathematical elegance, with many physicists captivated by the poetic harmony of its equations. Yet, one must ask how much of this beauty is a true reflection of reality, and how much is simply an intricate play of abstract numbers. Science often strikes a delicate balance between artistic intuition and rigorous logic, and string theory stands as a powerful testament to this dynamic interplay. When applied to the origins of the cosmos, string theory posits that the initial state of the Big Bang might have been dictated by these vibrating strings. Such a perspective could provide answers to fundamental questions about how and why everything came to be. If the vibration of these strings was the initial spark that ignited the cosmic fire, then every one of us could be fundamentally connected to that primordial, universal melody. As our exploration of string theory deepens, we inevitably confront the question of consciousness and its place in this framework. Is it possible that our conscious experience is somehow an extension of these fundamental vibrations? The concept that our very existence is woven into the essential fabric of the universe opens up fascinating new inquiries into the nature of life itself. The quest for a unified theory is more than just an intellectual pursuit. It is a profound journey to understand our own place within the cosmos. Should we succeed in unlocking the secrets held by these vibrating strings, we might move a step closer to understanding the true genesis of the universe. On this path, science and philosophy become intertwined, elevating our thoughts from the purely physical to the metaphysical. Ultimately, string theory transcends its role as a mere scientific model. It serves as a powerful call to human curiosity. It beckons us to explore the vast unknown, to challenge our assumptions, and to stand in awe of the universe's incredible complexity. Throughout this journey, each question we ask and every discovery we make brings us nearer to the essence of existence, as the cosmic symphony of strings continues its eternal dance with us as part of it. This possibility creates a new path for researchers to hunt for circumstantial evidence that points to the multiverse's existence. An intriguing concept born from this line of thinking is that some of these other universes might operate under physical laws so alien that life as we understand it would be impossible. Just consider a universe where the chemistry that sustains life is completely different, or where an element like oxygen is not essential at all. What incredible life forms could arise in such fundamentally different conditions? The multiverse concept also carries with it some very deep philosophical questions. If an infinite number of universes exist, each playing out different possibilities, what does that imply about our own reality and the choices we make? The idea that every decision spawns an entirely new universe could make you question the very nature of free will. Are you actually making choices, or are you just following a predetermined trajectory that already exists within one of countless cosmic frameworks? As Michio Kaku delves into these thoughts, He also brings up fundamental questions about our existence and purpose. In a vast multiverse with limitless variations, what is our significance? Is there an inherent meaning to our lives, or are we merely one of many possible outcomes in an endless sea of realities? In this arena, science and philosophy frequently intersect, prompting you to reflect on your place in the cosmos and your relationship to everything that surrounds you. Exploring the multiverse is not simply a mental exercise. It is a deep dive into the essence of existence itself. Ultimately, this idea challenges you to open your mind and confront everything we have yet to comprehend. Following Kaku's example, we must keep our curiosity and our drive to explore alive. It is entirely possible that the universe is far more magnificent and intricate than we have ever dared to imagine. Every new theory and every new question moves us slightly closer to unlocking the universe's greatest mysteries. Have you ever really stopped to consider the nature of time? It appears to be a straightforward measurement, but it is one of the universe's most profound enigmas. Within the fields of cosmology and theoretical physics, time is generally seen as a dimension that progresses from past to future. But what if I were to tell you that time itself was born at the very moment of the Big Bang? This is a startling concept that fundamentally challenges our ordinary sense of chronology. Time, as you and I perceive it, simply did not exist before the Big Bang. In the moments preceding that monumental event, the entire universe was compressed into a single point of infinite energy, where the very notion of time was meaningless. In this framework, time only started its forward march from the instant the universe began its expansion. To help you picture this, think of a stopwatch that only starts counting once it is clicked. The Big Bang was that initial click that set the clock of the cosmos in motion. This raises an important question. What is beyond the boundaries of time? Can you even conceive of a universe in which time does not exist? According to some scientific theories, the answer is yes. For instance, string theory, which investigates extra dimensions, suggests that time might just be one of many that construct our reality. This leads you to entertain the possibility of other realities, where time flows in a completely different manner, or perhaps doesn't flow at all. Trying to imagine a universe without time can be a mind-bending exercise, but it is essential for grasping how our own universe originated. In this context, Kaku proposes that time might be an illusion, a projection of the universe's immense complexity. Much like the individual static frames of a film create the illusion of a flowing story when played in sequence, time could just be a series of distinct moments that our consciousness perceives one after another. This perspective brings us to an intriguing puzzle. Could anything have existed before the Big Bang? If time itself began with that event, then the very concept of before becomes nonsensical. The universe as we know it started at that precise instant, and everything that has happened since is simply the gradual unfolding of what was contained in that initial cosmic explosion. This idea forces you to contemplate the origins of everything, and to soften the lines between past, present, and future. The deep connection between time and the universe also encourages us to think about the nature of destiny. If time moves forward along a single straight line, does that suggest that everything is already predetermined? Kaku invites you to consider that while time may have a single direction, the universe is so complex that it allows for countless possibilities. It's conceivable that every one of your decisions is a thread in an infinite tapestry of realities that exist simultaneously. The time paradox also reveals itself in our understanding of cause and effect. If time is a direct result of the Big Bang, How does that change our grasp of how events unfold? The principle of causality is a foundation of modern science. But if time itself is flexible, then our models of how events progress may need to be more adaptable than we previously thought. Within modern physics, time is now a subject of intense debate, with some theories postulating that it can behave in very unexpected ways. In the future, we may develop a much deeper comprehension of how space and time are fundamentally connected. It's possible we will learn that time is not merely a line connecting events, but an intricate fabric that interacts with energy and matter in ways we can't yet fathom. This exploration into time's nature also forces you to confront questions of existence and purpose. As Michio Kaku suggests, if time is an illusion, our experiences and memories could be part of a grander narrative that exists outside of time, inviting you to find meaning beyond its simple progression. The paradox of time ultimately compels you to consider the bond between humanity and the universe. How can you find a sense of belonging in a cosmos where time itself seems so transient? The answer might be found in the way you choose to live, in a search for significance within the boundless theater of the universe. The Big Bang wasn't just the cataclysmic event that created everything you see. It also represented the birth of time itself. To grasp this, you must examine how time is understood within the grand scale of the cosmos. In your daily life, you experience time as a linear progression. You live through a sequence of moments with a past that is fixed, a present that is ever fleeting, and a future that holds infinite possibilities. On the vast stage of the universe, however, time assumes a completely different character. Our current theories suggest that before the Big Bang, nothing existed. Not space, not matter, and not time. It was a state of absolute nothingness, a concept that challenges your very ability to comprehend a reality where time had no meaning. The conventional understanding holds that time began its journey with the Big Bang. In that singular moment, all matter and space were condensed into a point of infinite heat and density. As this singularity began its rapid expansion, time started to flow forward from that initial instant. You can visualize time as a great river, where each moment is a single drop of water. Before the Big Bang, there was no river and no flow. When the universe ignited, the river began to move, and every event since, every star born, every galaxy formed, has added another drop to this cosmic current. But what if this river of time isn't the only one? What if countless other rivers exist, each one representing a different universe within a multiverse? This idea that the Big Bang created time pushes you to question the very fabric of reality. If time is a dimension akin to space, perhaps other temporal dimensions exist that you are not yet able to perceive. Imagine a universe where time flows backward, or one where each moment is not part of a sequence, but an endlessly repeating cycle. As you travel deeper into the study of cosmology, you encounter questions that defy conventional logic, such as why time seems to have a clear forward direction. The second law of thermodynamics offers a clue, stating that disorder, or entropy, in an isolated system always increases. This relentless march from order to chaos may be why you perceive time as a one-way street. If the universe is a book, the Big Bang wrote its first page, and every event since has filled another chapter, leaving the final pages for a future you cannot yet read. This line of thinking naturally leads to the question of time's ultimate fate. As the universe continues to expand, will time itself one day stop or be transformed into something else entirely? Some scientists propose that time may actually slow down in an ever-expanding cosmos. Picture a distant future where time is but a faint whisper, and events happen so infrequently that your perception of its passage becomes profoundly distorted. This paradox also makes you consider the link between time and consciousness. If time is a construct that appeared with the Big Bang, how does that influence your perception of reality? Human consciousness, with its unique ability to reflect on the past and anticipate the future, appears to share a special relationship with time. Perhaps your awareness is a direct manifestation of time itself, a cosmic mirror reflecting the universe's unending flow. It becomes clear that time is not just an abstract idea, but a vital thread connecting your small existence to the vast tapestry of the cosmos. Ultimately, can you truly understand the origin of time without first understanding your own existence within it? The Big Bang, by giving birth to time, invites you to contemplate your own role in this immense and evolving cosmos. You are a temporal being in a universe that is itself a product of time. Each new theory and every experiment brings you a step closer to understanding not only the universe, but also yourself, because the story of time is inextricably woven into the story of everything.
This raises one of the most fascinating questions of all. What are the physical laws that allowed the universe to be created in the first place? From the very instant the cosmos began to expand, a distinct set of principles and laws has governed its evolution. Physics, in its most fundamental form, is your ongoing quest to decipher these cosmic secrets and understand the rules that orchestrated the creation of reality itself. When you consider creation, your mind might conjure images of a magical act or some singular, extraordinary occurrence. The truth, however, is that the universe's formation is governed by physical principles that are as profoundly complex as they are magnificent. For instance, the very force of gravity that anchors you to the Earth also orchestrated the assembly of galaxies, stars, and planets, without which the cosmos would remain a shapeless and chaotic void. Beyond gravity, energy stands as another pillar in the architecture of the universe. As Einstein's renowned equation demonstrates, mass and energy are interchangeable, meaning everything you perceive possesses an inherent energy. This fundamental energy not only propelled the universe's expansion following the Big Bang, but was also essential for the very formation of matter, implying that you are part of an immense energetic web that connects all of existence. Our understanding of creation is also deeply intertwined with the laws of conservation. These principles dictate that matter and energy cannot be created or destroyed, only transformed from one state to another. Applied to the Big Bang, this suggests that the entirety of matter and energy present today existed in a primordial state at the dawn of time. This naturally raises the question of where it all resided before the expansion began, a query that pushes us to the very edge of our comprehension, where physics and philosophy converge. Symmetry represents one of the most vital keys to unlocking the secrets of creation. Throughout nature, you can see recurring patterns, from the elegant arrangement of petals on a flower to the majestic spiral of a galaxy. These are not random occurrences, but fundamental principles governing the behavior of matter and energy. When such a symmetry is broken, often under extreme conditions, truly astonishing phenomena can arise, making one wonder what we could achieve with a deeper grasp of these concepts. String theory provides another captivating perspective on our origins. This framework proposes that subatomic particles are not dimensionless points, but minuscule vibrating filaments of energy. The specific frequency of these vibrations dictates the properties of the particles that constitute everything you know. If you imagine the universe originating from a single primordial vibration, then creation itself can be perceived as a grand cosmic symphony, an ongoing piece of music that gave birth to all reality. The nature of time is an equally fascinating component of creation. It's possible that time itself was born in the Big Bang, an idea that fundamentally challenges our linear perception of its flow. This concept suggests that before the universe began expanding, time, as you understand it, simply did not exist. Such a notion compels you to completely rethink your relationship with the past and the future, and how this dynamic shapes your existence. The physics of creation inevitably leads to the enigmatic subjects of dark matter and dark energy, which are crucial cosmic components that remain largely beyond our grasp. These mysterious forces not only constitute the vast majority of the universe's mass and energy, but also dictate the rate of its expansion. Given that these elements are so foundational to the process of creation, one can only speculate what other incredible discoveries await us as we investigate them further. To find answers, the scientific community engages in a continuous effort to test these theories through numerous experiments. From immense particle colliders to powerful telescopes peering into the universe's infancy, every new piece of data moves us closer to comprehending the laws that govern all creation. The challenge remains: how to continue unraveling these profound mysteries scattered across such an immeasurable and seemingly incomprehensible cosmos. Contemplating the physical laws that enabled the universe's existence prompts you to reflect on your own being. As a direct product of these cosmic rules, you are an observer within a universe that has unfolded over billions of years. Each of us is a manifestation of the very same forces that forged stars and shaped worlds. Instead of a singular event in the distant past, creation is a continuous process, and every moment you live is a fresh expression of the universe's fundamental laws. This undeniable link between your daily life and the grandeur of the cosmos invites you to view the universe not merely as a physical domain, but as a dynamic environment where you have a part to play. It is at this junction that science and philosophy often meet, as a deeper exploration into the laws of creation inevitably raises existential questions. In this vast, interconnected reality, you are led to ask about your place in the cosmos and the ultimate purpose of your existence. Ultimately, when you examine the physics behind creation, you find that each answer only uncovers a new layer of questions, ensuring the quest for knowledge is truly endless. Every scientific breakthrough fuels our drive to explore, to question, and to marvel at the universe's complexities. It is a realm teeming with mysteries, and you have the unique opportunity to participate in this grand adventure of discovery, driven forward by the insatiable engine of human curiosity. This exploration naturally extends to one of the most captivating questions of all. Does life exist elsewhere in the universe, or perhaps even in parallel realities? This inquiry inspires scientists, philosophers, and dreamers in equal measure, as the notion that we may not be alone is as thrilling as it is profound. Michio Kaku, a prominent theoretical physicist, encourages us to consider this possibility through the lens of the multiverse, where life could be far more prevalent than you currently imagine. In this vision, an infinite sea of universes exists, each with unique conditions and even different laws of physics, completely redefining the potential for life. Given the sheer scale and unpredictability of the universe, the presence of life in other corners of reality seems not only feasible, but almost certain. This search for extraterrestrial existence compels us to ask profound questions about the essence of being. What does it truly mean to be alive? Is it just an intricate arrangement of atoms and molecules, or is there some other, unseen component? While science works to formulate a clear definition of life, much remains a mystery, and in a cosmos with such wildly varying conditions, life could emerge in forms you can scarcely comprehend. The multiverse theory, in this context,
proposes that life might manifest in ways that completely upend our conventional understanding. You could picture it like watching a collection of different movies, where each one possesses its own unique plot, cast of characters, and setting. In the same way, every universe could tell its own distinct story, with life adapting to its specific physical laws. This concept also introduces the possibility that in some of these universes, life has thrived under circumstances that would be considered utterly hostile in our own, such as a world where some other liquid replaces water as the basis for life, or a reality where organisms are built from silicon instead of carbon. As we delve into these fascinating concepts, you naturally begin to wonder if we will ever uncover tangible proof of life in these other universes. This is where theoretical physics offers some guidance. Even though we lack the ability to directly perceive other universes, scientists are constructing models and theories that could allow us to infer their existence. For instance, the physicist Michio Kaku has explored how quantum mechanics and string theory might hold clues about the fundamental nature of the multiverse itself.
The idea of a multiverse also forces us to re-examine the destiny of life. If an infinite number of universes exist, does that imply that in some of them, even the choices you make today could unfold differently? These are captivating thoughts, suggesting that every decision could potentially branch off into a new universe with a completely separate outcome. In this light, life itself transforms into a vast cosmic experiment, and each of us becomes a miniature universe of our own. However, the conversation is not merely about whether life exists elsewhere. It also brings our own significance into question. If life is indeed commonplace throughout the multiverse, what does that reveal about our place in it all? Are you here as a result of pure chance? Or is there a greater design woven into the fabric of the cosmos? The answers to these inquiries are profoundly philosophical, urging us to contemplate our connection to the universe on a much more intimate level. As scientific capabilities advance, the search for life in distant cosmic regions is becoming more achievable, with missions to Mars and the study of exoplanets serving as our initial steps. Yet, the notion of life in alternate universes presents a far more intricate challenge. If these universes are beyond our ability to observe or travel to, how can you even start to grasp what might thrive within them? Scientists continue to speculate on the conditions necessary for life, and the emerging field of astrobiology is dedicated to this very pursuit. From the hidden oceans of Jupiter's moon Europa to planets orbiting within the habitable zones of other stars. The possibility of life in other universes also encourages us to think about the diversity of our own human experience. If a universe exists where your choices were different, what might your life look like in that alternative reality? This idea that you might have followed other paths in separate timelines prompts a reflection on the true weight of the decisions you make right here, in this universe. It elevates the search for extraterrestrial life from a simple scientific question into a profound exploration of our own place within the grand cosmic scheme. Ultimately, this quest reminds us that while you may sometimes feel isolated, the universe is an immense and enigmatic place. As we persist in our exploration and search for answers, we might one day find that we are not quite as alone as we once believed. This search could prove to be one of humanity's most exhilarating endeavors, a grand adventure that mirrors our intrinsic curiosity and our deep-seated need to understand the magnificent mystery that surrounds us. Human consciousness has been a source of endless fascination across history, captivating everyone from ancient Greek philosophers to contemporary scientists. The question of what consciousness is and how it relates to the universe remains a central puzzle. Is it simply a byproduct of neural activity in the brain, or does some deeper connection link our minds to the cosmos? Michio Kaku, a celebrated theoretical physicist,
invites you to consider this very intriguing link between our consciousness and the universe.
When you think about how consciousness might be tied to the vastness of space, it's crucial to remember that you are an integral part of something much larger. Every one of us is composed of atoms that were forged in the hearts of stars long ago, meaning that when you look up at the night sky, you are essentially looking at your own origins. Could this cosmic heritage imply that we are all connected in ways that transcend the known laws of physics? The idea that consciousness itself could be a fundamental property of the universe is a concept Kaku has examined in depth. Imagine for a moment that consciousness is not merely an outcome of biology, but a phenomenon that appears in countless forms all across the cosmos. Just as matter can exist in different states, perhaps consciousness can too. This line of questioning encourages you to rethink what it means to be conscious, and how that state of being is woven into the very structure of reality. For centuries, the notion that consciousness might exist independently of any physical form has been a subject of intense debate. Certain philosophical traditions propose that consciousness is a primary force of nature, comparable to gravity or electromagnetism. According to this viewpoint, consciousness did not simply appear with the emergence of life. It has been a fundamental component of the universe since its very beginning. If this were true, it would profoundly alter our entire understanding of life and existence itself. Kaku also puts forward the idea that our own consciousness could have a hand in shaping reality itself. In this view, you could imagine that your thoughts and perceptions directly influence the world you experience. Could it be that the universe, in some profound sense, acts as a reflection of our collective mind? This notion finds parallels in quantum physics, where the act of observation seems to alter the behavior of particles, prompting the essential question: is our consciousness the very key to deciphering the universe's greatest secrets? Driven by this possibility, some scientists are now investigating the link between consciousness and quantum effects, trying to grasp how the human mind might interface with physical reality. This line of inquiry leads to a compelling question. If our consciousness can indeed influence the universe, could we, in some fundamental way, be the architects of our own existence? The concept of a universe engaged in a continuous dialogue with our awareness directly challenges our traditional understanding of cause and effect. Consciousness might also be envisioned as the unifying thread that connects every living thing. From this perspective, if we are all woven into the same cosmic tapestry, what is the collective impact of our awareness on the well-being of the universe at large? Kaku contends that our very state of being conscious bestows upon us a profound responsibility to the cosmos, asking you to imagine a reality where consciousness is not a random byproduct, but an integral feature of existence. If human beings and other life forms possess the ability to perceive and comprehend the universe, it might imply that consciousness serves a higher function. Could it be that conscious life is the mechanism through which the cosmos becomes aware of itself? Such a concept suggests that your every thought, feeling, and action sends ripples through the immense fabric of space and time, giving each internal moment a cosmic significance. Furthermore, Kaku considers how consciousness may intersect with concepts of spirituality. Within numerous spiritual traditions, consciousness is treated as a sacred force that connects the human experience to the divine. When you look at the universe through this lens, it becomes possible to see science and spirituality not as adversaries, but as two sides of the same coin, each on a quest to answer the ultimate questions of life. This profound connection between consciousness and the universe compels you to reevaluate your own identity. If you are truly an inseparable part of the cosmos, then what does it really mean to be human?
Perhaps we are fated to move beyond our physical constraints and venture into entirely new dimensions of being. The idea that consciousness itself can evolve and grow points toward an exciting future in which humanity could forge new relationships with the universe. Ultimately, investigating consciousness within the cosmic framework is more than just a scientific problem. It becomes a deep philosophical journey. It offers each of us a chance to contemplate our place in the cosmos, and through that reflection, we might discover a renewed sense of purpose and belonging. In the grand design of the universe, it's possible that our awareness is a guiding light, illuminating the path to a more profound comprehension of our own existence. As we consider the link between our minds and the universe, we face a mystery that beckons us to press forward with our exploration. The very human trait of curiosity, the engine that powers our search for knowledge, may be one of the most incredible gifts bestowed upon us by the cosmos. With every question you ask on this path of discovery, you may move closer to understanding not only who you are, but why you are here. Is it conceivable that all the laws of physics are woven together, forming the pieces of a single cosmic puzzle? This pursuit of a unified theory has long captivated the minds of both scientists and philosophers. Since the dawn of human thought, we have tried to decipher the fundamental rules that govern our universe. The reason this unification is so vital, though seemingly intricate, is that it is essential to unlocking the deepest secrets of reality. Imagine you are playing a complex video game where each level operates under its own distinct rules, yet all are ultimately governed by the same underlying code. In physics today, we possess several separate fragments of this cosmic rulebook. Einstein's theory of relativity, which masterfully explains the behavior of very large objects, and quantum mechanics, which describes the bizarre realm of subatomic particles, function like two different languages that cannot translate one another. How is it possible for an immense object, such as a black hole, to function so differently from a single, tiny particle of light? This very paradox is what has compelled researchers like Michio Kaku to chase the vision of a unified theory. As Kaku explains, achieving this unification is indispensable for comprehending the true nature of the universe in its entirety. This leads us to ask, what holds the key to finally bringing these ideas together? Among the most promising candidates for this unification is string theory. If you've ever experimented with creating patterns by plucking a string, you can grasp the basic concept. String theory posits that the most fundamental components of reality are not points, but tiny vibrating filaments of energy. These strings oscillate at various frequencies, and their unique vibrations determine a particle's properties, potentially providing a clear path to uniting all of nature's forces. But what is the connection between this theory and the birth of our universe? If all the fundamental forces are indeed interconnected, it suggests that the Big Bang not only created the cosmos, but also simultaneously established all the rules that direct it. Therefore, our search for a unified theory is not just an attempt to understand the present, but also a journey into the distant past to uncover what transpired in the first moments of creation, at the junction of relativity and quantum mechanics. This notion of unification also opens up profound questions regarding the ultimate fate of the universe. Should we succeed in unifying the forces, we might gain the ability to accurately forecast the cosmos's future. Are we headed for a slow, eternal decay, or is existence part of a grand cycle of birth and destruction? Every new insight gained in this quest moves us another step closer to solving the enigma of time itself. To understand this, you might think of an orchestra conductor. While each musician has their own instrument and unique score, it is the conductor who brings them together to produce a harmonious symphony. In the world of physics, A unified theory would serve as that conductor, revealing how all the seemingly separate forces of nature are actually playing the same cosmic melody.
If we could discover it, we would finally grasp how all the fundamental forces of the universe are interconnected and how those relationships have sculpted the reality you and I experience. This is no simple undertaking, however, as scientists are in a constant search for experimental proof to validate their theories. From the Large Hadron Collider to vast astronomical surveys, every new piece of data might hold a clue to unifying the laws of physics, making you wonder what breakthroughs just over the horizon could reshape our entire cosmic perspective. Throughout the history of science, many of the greatest minds have devoted their entire lives to this singular objective. From Albert Einstein to Michio Kaku, they have all shared the dream of witnessing the moment a single, unified theory is finally unveiled. That passionate quest is very much alive today, and each new success inches us closer to the ultimate answer. But the question remains, is it truly possible to distill all of existence into a single, elegant equation?
The search for this unification also carries profound philosophical weight. If it turns out that all forces are merely different aspects of one underlying principle, what would that imply about your understanding of reality itself? It suggests that everything is connected in ways we have yet to even imagine. These are not just challenges for physicists. They are invitations for anyone who dares to contemplate the universe to pause and reflect on its nature. As we delve deeper into these ideas, the practice of science transforms into a thrilling expedition into the unknown. It is human curiosity that propels us to chase after answers, and every discovery seems to unlock new doorways to realms of knowledge that are still concealed from us. Achieving a unified theory of physics might just be the next great leap in our cosmic awareness, bringing together not only the forces of nature, but also our deepest questions about our own place within it all. This is a journey filled with ambiguity, yet every attempt to find a solution is a firm step in the direction of greater knowledge. While the final outcome of this grand search remains uncertain, our innate curiosity and the powerful desire to understand are the engines that drive us forward. Ultimately, the story of science is the story of discovery, and the quest for a unified theory stands as one of the most compelling chapters we are currently writing. What if I were to tell you that the solutions to some of the most fundamental questions about the universe's birth might be found in experiments that haven't even been performed yet? In their effort to comprehend how everything began, scientists have devised remarkable methods to test theories about the Big Bang and the ongoing expansion of the cosmos. You can think of each experiment as a unique portal, giving us a glimpse back in time toward that initial, primordial moment. One of the most captivating of these experiments makes use of particle colliders, most famously the Large Hadron Collider, or LHC. You should picture these immense machines as laboratories, designed to recreate the conditions that existed fractions of a second after the universe was born. Within this controlled space, infinitesimally small particles are smashed together at astonishing speeds, producing a burst of chaos that could mirror the energy and state of the early cosmos. By analyzing these collisions, we wonder if we are witnessing the very fragments of creation itself. This naturally leads you to ask what we can possibly learn from these violent impacts. By carefully studying the new particles that emerge from these explosions, researchers hope to find clues about dark matter and dark energy, the mysterious components that constitute the vast majority of the universe. It is as if we are finding the missing pieces of a grand cosmic puzzle, and each new piece we fit into place gets us closer to seeing the complete picture. Beyond these earthbound colliders, we also have powerful telescopes that peer into the farthest reaches of space. Have you ever considered what secrets are locked away in the most distant galaxies? By employing instruments like the Hubble Space Telescope, scientists collect data that tells the story of how the very first stars and galaxies came into being. When you look at light that has journeyed for billions of years to reach us, you are effectively seeing the universe as it existed in its infancy, like opening a photo album from the childhood of the cosmos. On another front, we now have the ability to study gravitational waves. These are ripples in the very fabric of space-time, which were first predicted by Einstein, and their successful detection has provided a completely new avenue for cosmological research. These waves offer us information about unimaginably violent events, such as the merging of two black holes. Each time one of these cosmic tremors is registered, you are given a new way to observe the universe, almost as if we are tuning into a celestial broadcast telling the stories of its formation. Computer simulations also perform an indispensable function in this quest for knowledge. Scientists construct complex digital models that can simulate the universe's behavior under an array of different physical laws. You can then ask, what might have happened if we were to adjust the fundamental constants of nature within these models? Through such simulations, we can explore alternative histories and possibilities that may have shaped the universe's evolution, pushing our understanding beyond the boundaries of what we can directly observe. Every one of these experiments serves a very direct purpose, to either confirm our current theories or prove them wrong. But what is the outcome when a theory does not survive this rigorous testing? This is precisely how science makes progress, through a constant process of doubt and revision. Each time an experiment produces an unexpected result, it forces us to ask new and better questions. This is the very foundation upon which our knowledge is constructed. The most fascinating part of these experiments is that they are designed not only to provide answers, but also to generate entirely new mysteries. Every time we learn something new, we almost invariably realize that the scope of what we do not know is even larger than we previously thought. This is the fundamental cycle of science, an endless interplay between discovery and uncertainty. Who can possibly guess what new surprises are waiting for us on the horizon? The dynamic relationship between theory and practical experimentation is absolutely essential to this process. Experiments do more than just test existing ideas. They often serve as the inspiration for entirely new theories. Whenever a scientist observes a phenomenon that doesn't align with our current models of the universe, a fresh path toward new questions and possibilities opens up. In that sense, you can view experimentation as a continuing dialogue between human thought and the universe itself, where international collaboration is also a cornerstone of this search. As scientists from all over the world contribute their expertise, each experiment becomes a truly collective human endeavor. This kind of synergy lets us pool our knowledge and resources, which significantly speeds up the pace of discovery. Isn't it incredible to consider that the key to understanding the universe might rest in the hands of a team spread across different continents? Ultimately, every experiment we undertake is not just an effort to comprehend the past, but also a way to prepare for what lies ahead. By figuring out how the universe came to be and how it has changed, you and I equip ourselves with the insight needed to tackle questions about our own place within it all. What is our purpose in this immense cosmos? And are we the only ones here in this vastness? So, the next time you look up at the night sky, I want you to remember that each star is a part of the grand story we are all working to piece together. The research being done today builds the very foundation for the cosmology of tomorrow. Every new finding moves us one step closer to solving the great mystery of the universe and, just maybe, to understanding who we are on this extraordinary cosmic journey. Modern cosmology has profoundly reshaped our view of the universe. Ever since scientists first started probing the edges of the cosmos, They have made discoveries that fundamentally challenge our perception of what is real. How could something so immense and intricate as the universe originate from such a precise beginning? The answer to that question can be found by tracing the evolution of cosmology through the decades. A cornerstone achievement in this field is the development of the Big Bang theory, but this is really just the starting point of a much larger story. As you and I venture deeper into the study of the cosmos, we've come to understand that there are far more forces at work than we ever first imagined. What is the engine driving the expansion of the universe, and how does it relate to the very creation of everything we can see and touch? Telescopes have been absolutely essential to this progress, but I wonder if you knew that they don't just peer into space. They also serve as time machines. Each time you observe a distant star, you are actually seeing light that began its journey millions or even billions of years ago, giving us a window into the universe's infancy. Contemporary cosmology, however, extends far beyond the Big Bang. It introduces ideas that sound like they belong in science fiction, such as dark matter and dark energy. How can it be that the majority of the universe is composed of something you can't see or physically interact with? This concept may seem strange, but it is critical for explaining the cosmos's structure and behavior. These enigmatic elements not only dictate the movement of galaxies, but are also central to understanding the universe's accelerating expansion. Speaking of this expansion, what does it truly signify when we say the universe is constantly growing? Picture a balloon being filled with air. As it inflates, every point on its surface moves farther away from every other point. This simple analogy helps illustrate how galaxies are receding from one another. And as the universe continues to expand, it opens up new lines of inquiry. What might exist beyond the edge of our observable cosmos? Is it possible that other universes exist parallel to our own? Cosmic inflation represents another vital component of this cosmic puzzle. This theory posits that in an infinitesimally brief period right after the Big Bang, the universe experienced an explosive and incredibly rapid expansion. But why does this fleeting moment matter so much? Grasping the concept of inflation helps us understand how the large-scale structures you see today, from individual galaxies to massive galactic clusters, originally took shape. It's akin to knowing how a complex landscape was sculpted from an initial swirl of dust. Furthermore, how does the concept of symmetry tie into the origin of the universe? In the realm of physics, symmetry is a profound principle that assists scientists in formulating the laws of nature. The physicist Michio Kaku points out that the elegance and harmony we observe in these physical laws might be woven into the very fabric of the cosmos. This relationship between symmetry and the universe's beginnings raises compelling questions about the fundamental nature of reality itself. String theory, which stands as one of the most captivating proposals in modern physics, pushes these boundaries even further. It asks you to imagine that subatomic particles are not just dimensionless points, but are instead tiny, vibrating strings of energy. The specific manner in which these strings vibrate could hold the secret to unifying all the fundamental forces of the universe. Could a more profound knowledge of these strings allow us to finally unravel the mystery of how our universe began? When you introduce the idea of the multiverse, the possibilities expand exponentially. If other universes are indeed real, what would that imply for our understanding of life and the cosmos? Could our existence be just one among countless cosmic experiments? These inquiries have ignited philosophical and scientific debates that continuously push the limits of our concepts of reality and being. As our exploration of the universe progresses, the paradox of time inevitably comes into focus. If the Big Bang was the genesis of time, what could have existed before it? Is it conceivable that time is nothing more than a construct of our own perception?
These thoughts lead us to question our very existence and the part we play on this grand cosmic stage. The physics of creation itself is another area of immense fascination. The laws that permit the universe to exist might also contain clues about its ultimate purpose. Could there be an underlying design to everything you and I observe? Such questions create a space for conversations that bridge the gap between science and spirituality. Looking ahead, current and future experiments, from the Large Hadron Collider to gravitational wave observatories, promise to carry us even deeper in our quest for answers. As our technology advances, our comprehension of the universe deepens, and each new discovery paves the way for a new set of questions. Modern cosmology, in all its complexity and wonder, reveals that the universe is a place brimming with surprises. Every breakthrough not only provides you with a new lens through which to view the cosmos, but also invites a profound reflection on our own place within it. The pursuit of knowledge is an endless voyage, and as Kaku so skillfully expresses it, the exploration of the universe is an adventure we have only just begun. These kinds of questions not only propel our exploration of physics, but also carve out a vast domain for philosophical thought. In this way, science and philosophy function as two faces of a single coin, where each cosmological breakthrough forces us to reassess our entire perception of the world. How does what you understand about the universe's beginnings shape your identity as part of humanity? When you gaze into the night sky, are you just a passive observer, or is there a more profound connection at play? The notion that everything you perceive emerged from a cosmic detonation over 13.8 billion years ago prompts a deep consideration of our position within the grand tapestry of space and time. If the universe is truly this ancient and expansive, what bearing does that have on your day-to-day existence? Each of you is the culmination of an immense sequence of events that started in that initial, primordial moment. Your entire understanding of time is redefined when you begin to study the origin of the cosmos. Is time a linear progression moving inexorably forward, or does it resemble a cycle where all things are intertwined? Michio Kaku posits that the Big Bang didn't just give birth to the universe. It also forged the very structure of time as you experience it. This leads to a perplexing question. If time itself started with the universe, what could have possibly existed before the Big Bang? Some theoretical frameworks suggest that time might be an emergent quality, a consequence of the fundamental interactions within the cosmos, which in turn leads you to reflect on the nature of being itself. Philosophy also compels you to contemplate the idea of purpose. If the universe truly originated from nothing, is there any intrinsic meaning to its existence? Are you here purely by accident, or are you part of a much larger design? The most profound questions of life, including the search for meaning and a sense of purpose, stem from the very same curiosity that fuels scientific investigation. Kaku highlights that science and spirituality are not mutually exclusive. They can coexist, with each providing a unique lens through which to view the human condition. When you consider the potential of a multiverse, philosophy ventures into even more captivating territory. If countless universes do exist, each with its own distinct reality, what does that imply for your concept of free will? Are you genuinely making choices, or are your lives simply expressions within an infinite array of possibilities? While this idea can seem disorienting, it also offers a sense of liberation. It encourages you to view your life as a single thread in an enormous web of realities, where every decision might unlock an entirely new path. The study of dark matter and dark energy also challenges you to re-examine your fundamental beliefs about the cosmos. Given that these mysterious forces constitute the vast majority of the universe, what does that reveal about your grasp of reality? Science demonstrates that there is substantially more to existence than what your senses can detect, pushing you to accept the limits of your own perception and recognize that reality is likely far more intricate than you imagine. So, where do science and ethics converge in this conversation? As your comprehension of the universe and its origins deepens, you are confronted with new ethical quandaries. The power to manipulate nature and use technology for cosmic exploration brings up pressing questions about your responsibility as a species. Are you truly equipped to manage the authority that this knowledge bestows? The choices you make today could very well shape humanity's future interactions with the cosmos. The link between consciousness and the universe is another avenue ripe for exploration. Is your awareness simply an evolutionary side effect, or does it represent something more fundamental? Certain philosophers propose that consciousness is a reflection of the universe itself, a mechanism for the cosmos to comprehend its own existence. This perspective invites you to consider that, as sentient beings, you might play an active role in the fabric of reality. Perhaps the dialogue between science and spirituality is what allows you to fully appreciate the sheer beauty of the universe. The elegance of physical laws and the breathtaking wonders of the cosmos are not merely objects of academic study. They also evoke a profound sense of awe and reverence. While science provides explanations, the raw experience of cosmic magnificence can resonate on a much deeper, more personal level, suggesting that the pursuit of knowledge and the appreciation of beauty might be two distinct paths toward the same truth. As you advance on this journey of discovery, it is crucial to remember that the questions are just as significant as the answers. It is curiosity that compels you to continue probing the mysteries of the universe. Michio Kaku serves as a reminder that in confronting the unknown, you also challenge your own convictions and broaden your consciousness. With every answer you uncover, a host of new questions emerges, and it is within this dynamic space of inquiry that the true essence of humanity resides. Ultimately, exploring the genesis of the universe invites you to become part of a narrative far grander than your individual lives. It reinforces that you are all fragments of a vast, interconnected whole, woven together across time and space. In this collective endeavor to understand your place in the cosmos, scientists like Kaku demonstrate that science is more than a collection of theories and equations. It is a shared odyssey of comprehension, a path you can all travel together, where every person has a part to play in the unfolding story of the universe. What role, then, can spirituality have in a cosmos that appears to operate under strict physical principles? When discussing the relationship between science and spirituality, Michio Kaku prompts you to think about how these two domains can coexist and enrich one another. Science, with its focus on observation and experimentation, strives to decode the universe's enigmas. Spirituality, in contrast, offers a sense of connection and purpose within that immense cosmic expanse, raising the fascinating question of whether science can ever address matters traditionally considered spiritual. The universe captivates you not just with its formulas and laws, but with its profound capacity to awaken a sense of wonder. For centuries, thinkers have debated whether our cosmos has an intrinsic purpose, with some seeing a grand design in the complexity of life. I believe, as Michio Kaku points out, that science excels at explaining how things work, but doesn't necessarily provide the answer to why, leaving that search for meaning as a deeply personal journey for you.
When you reflect on cosmological theories like the Big Bang, you are naturally led to contemplate your own place within this immense and unpredictable reality. This line of thinking prompts an essential question. What is our role in this cosmic expanse? Kaku suggests that by comprehending our environment, you begin to access a type of knowledge that goes beyond mere facts and figures, framing humanity's story within a continuously unfolding universe. This quest for cosmic answers can also bring you a sense of solace. In the face of life's great uncertainties, scientific frameworks can coexist harmoniously with spiritual beliefs rather than opposing them. For instance, the scientific fact that you are composed of stardust, elements forged in distant stars, can be seen as a powerful metaphor for your connection to the cosmos, echoing spiritual traditions that teach the unity of all existence. The place of consciousness within cosmology raises even more fascinating questions for you to consider. Is your awareness simply a random outcome of evolution, or does it represent something more fundamental? Kaku puts forward the idea that consciousness might be an inherent property of the universe, much like gravity. This perspective suggests that you are tied to the cosmos in ways we are only beginning to grasp, opening a rich dialogue between science and spirituality. The concept of the multiverse also invites you to stretch your imagination, challenging your understanding of purpose and reality. If there are countless other universes, each with unique laws and possibilities, what does that imply about your own life? While the thought can be staggering, it also offers a liberating view where every choice creates a new reality, giving each existence its own profound significance across the cosmic web. I feel that your own capacity for awe when you gaze at the stars is, in itself, a spiritual experience. Science gives you the map to explore the universe, while spirituality encourages you to navigate the inner landscape of your feelings. These two paths are not opposed. They are complementary parts of a single journey. Ultimately, the pursuit of knowledge, whether through a telescope or through introspection, is a fundamental part of what makes you human in this astonishingly vast universe. Michio Kaku posits that consciousness itself might be a fundamental component of the cosmic architecture, a viewpoint that encourages you to reflect on how your thoughts and actions are woven into the very fabric of reality. This search for an underlying unity in the laws of physics echoes the profound idea that all things are interconnected, creating a powerful resonance between our inner world and the outer universe. As physicists strive to reconcile grand theories like relativity and quantum mechanics, they inevitably confront new and fundamental questions about the universe's origins. This raises the ultimate query. Could a single, elegant law govern everything that exists? This scientific quest for unification is a mirror of your own innate search for meaning and order within a cosmos that can often appear random and chaotic. The philosophical consequences of such discoveries are immense, compelling you to fundamentally reconsider your perceptions of reality, existence, and your specific role within the grand cosmic scheme. If everything is truly interconnected, how does that transform the nature of your relationships and the weight of your decisions? Each breakthrough in science introduces new layers of complexity, yet it also presents you with an opportunity to uncover a deeper sense of purpose. In this framework, science and spirituality, which you might have viewed as opposing forces, can actually coexist and enrich one another. Kaku's perspective suggests that by scientifically comprehending the universe, you can also engage with timeless, spiritual inquiries about existence and meaning. Far from diminishing your sense of wonder, science has the power to amplify it, adding profound depth to your experience of life. The history of the cosmos, from the Big Bang to the evolution of life, is an extraordinary narrative that invites you to participate in something far greater than yourself. Every star that you see in the night sky, and every atom that makes up your body, is a direct consequence of a cosmic saga that has unfolded over billions of years. This deep sense of connection can inspire you to protect our planet and to work toward a future where life flourishes in harmony with the cosmos.
Ultimately, the invitation from thinkers like Kaku is for you to never stop exploring. Each question you pose and every answer you uncover brings you a step closer to deciphering the universe's greatest mysteries. While you may never possess all the answers, the journey of discovery is inherently meaningful, propelled forward by the twin engines of curiosity and the deep-seated desire to understand. Looking ahead, you can only speculate on how science will continue to revolutionize your understanding of both the universe and yourself. What groundbreaking new theories will arise, and which revolutionary experiments will utterly shift your perspective? The cosmic story is far from complete, and you are an active character in this ever-unfolding epic, where each scientific advance serves as a fresh reminder that the universe is a place of infinite wonder. As this exploration of cosmic origins draws to a close, remember that the pursuit of knowledge is an unending journey. The splendor of the universe is found not just in its sheer vastness, but in your ability to be moved by it and to ask profound questions. Human curiosity is the driving force that propels us all forward, making the exploration of the cosmos one of the most thrilling adventures you can ever undertake. So, continue to question, continue to seek, and above all, never stop dreaming.